Hello everyone, welcome back to my channel. Today let's go over a binary search hard problem that I've just solved on my own. So I'm really happy about this because I tried a bunch of times and kept running into edge cases, but then I printed some things, I made some observations, and I was able to solve it on my own without any assistance. So again, I'm really excited about this. So let me show you how I did it. So basically you're given an integer array nums. And again, the question I don't think is too hard. You just want to return the number of pairs where for this, how many elements? When you times 2, nums of I is still bigger than that. So in this case, it's nothing. In this case, it's just 1. In this case, it's just nothing again. So just 2 in total. So here, for example, just find everything to the right where when you times 2 of that right number, it's less than the current number. And add together the pairs. So let's go ahead and declare an integer that we're going to return. And again, let me just show you the brute force that I used, which is length of nums, and then just really easily just say for j in range I plus 1 length of nums, everything to the right. If nums of I, the current element, is right here, is bigger than 2 times nums of j, then obviously we can increment answer. That technically works, but again, it's going to be too slow. So let's come up with a better approach, which I'll show you how I use binary search and a sorted list to solve this. And as you can see, it will probably time out. And there you go. So cool. So what do? Well, first of all, we have this array, right? Let's go ahead and create a sorted list of nums. And then what we do is say, let's print nums of I and SL after we discard nums of I, because that's just basically going to take everything to the right and have it in sorted order, right? So let's go ahead and submit this just to see. Okay, so 1, everything to the right, sorted order. 3, everything to the right in sorted order. 3, everything to the right in sorted, or 2, everything to the right in sorted order, as you can see. And then that makes it really easy because what you can do now is just use a binary search to count how many pairs satisfy this condition. So 1, obviously nothing times 2 is going to be less than 1, or 1 is going to be bigger than whatever times 2 that number is. Here it's just going to be 1. Here it's just going to be nothing. Here it's just going to be 1. And obviously if you don't have a sorted list, then you can't even do the binary search. So let's say if SL, then there are no pairs, there are no complements to this number that satisfy the times 2 condition. So cool, let's just go ahead and use binary search and say length of SL minus 1 while left is less than or equal to right, and just find that pivot point, right? So how many pairs? Well, we're just going to take, okay, we're going to say this one, it's not, so we're going to go down. This one, it's not. This, we're going to say this one, it's 4, it's not, it's too big. We're going to go down, it is. So then when we have one element, your mid index is going to be 0, right? But you have to plus 1 because 0 plus 1 is actually one element. So let's say mid, that's the index, right? And the value is actually SL of mid. And then again, if nums of I, the same condition, is bigger than 2 times the value, then let's print mid just so you can see. And then, okay, cool. So we found something that's valid. Cool, we can do everything up to this point. So let's try to look for a bigger number, right? Left equals mid plus 1. Because if 1 times 2 is less than 3, then let's say maybe 2 times 2 means less than 3. It's not, then we know this is the answer, right? Otherwise, if it's less than or equal to, then obviously we want to find a smaller number because, for example, 2 times 2 is 4 is too big, is not less than or equal to 3. So then we throw away the right half because this is already in sorted order from decreasing to increasing left to right. And let's go ahead and submit this. Cool. So you can see for 3, you only have index 0 that satisfies it. You only have index 0, so it's going to do mid plus 1, right? And then now for each turn, we have to find how many pairs satisfy everything to the right. So we're just going to take the maximum of mid plus 1 at each turn, each subarray, because now that's just going to give us what we need to say, okay, that's the rightmost point that times 2 is still less than 3. So let's add however many that index was plus 1 to offset it. So let's go ahead and submit this. Okay, output limit exceeded. Let's get rid of this. And And there you go, passes all test cases. So again, I'm really happy I was able to solve this on my own without any assistance, even though the runtime is not great. Again, it's not too often I solve a hard problem with a low acceptance rate on my own. So again, just pretty happy about this. And yeah, that's it for this video. Thank you for watching and stay tuned for more.